today with Hevo, the topic of webinar is building production-ready pipeline, production-ready data products on Snowflake using AI. And to help us, walk through how this happens, how we can actually achieve it, what is the problem statement that we are trying to solve, we have Mandeep, who is a data platform architect at Texas Capital and also a Snowflake Data Superhero. I, Kushagra, will be giving you also a walkthrough of all the problem statement from a Hevo side, but predominantly how we build the data product. Mandeep will do the heavy lifting today. So Mandeep, let's begin.
Absolutely.
Great. So what we'll cover today, the agenda is actually pretty straightforward. We're going to talk about the problem statement at first, the gap between data and decision making, how we're actually providing the solution to this gap using Snowflake data products with Hevo. Mandeep actually has a very good example for billing data products, and we're going to talk about how we will actually create these products. Before actually showing you how we activate these data products, we're going to talk about the foundation layers, how we architect the entire flow from start A to Z, building all the pipelines with Hevo, pushing data into Snowflake, followed by activating these data products on Snowflake. And whatever we've discussed so far, we're going to show you in the live demo how it actually happens with Hevo and Snowflake. And towards the end, we'll have a Q&A session. So Mandeep, we'll have a lot to cover. So I'll just begin by addressing the problem statement itself. The gap
Sure.
between data and decisions. Pretty used to topic, I would say, when it comes to analytics organization, adoption of AI. Just help us understand this problem statement in detail.
Yeah, thank you, Kushagra. As you can see, the slide says every organization has data flowing in multiple source systems from multiple source systems like MySQL, Postgres, CRM records, Salesforce, you call it, you name it, you have it. But the people who build those pipelines, build those ETL pipelines, they don't know what's the context of that is, what's the entire language it is. Neither they have the full picture. Same as the consumers as well. They they know the context, but they do not maintain the pipeline. That's where the gap is. That's where, if you can see, our on the left hand side, you have data producers who are the engineering team leads. They take up integration, transformations, scaling the data, doing the ETL pipelines, and making sure the raw complex data is reliable, trustworthy. Whereas data consumers, they just access the data, they just understand the context of the data and generate business value. What we saw and we captured is the gap. Gap is that generally we have seen any reporting, it takes 3 to 5 days to build. Kind of 40% of requests are repeat asks, whereas that's where the data products comes in, where it once created, it can be used multiple times. 1 in 3 metrics is has no clear owner. Somebody created a report 2 years back. Nobody knows who owns it, who runs it, where it belongs. 60 to 70% of decisions are made as per historical data. You know what? Last February we had this much of numbers. Maybe it should be near around that instead of having accuracy. That's where the delayed decisions, duplicate efforts, and the data that's technically accurate but practically unusable. That's where the data products fix this.
That's such a good point to start with. Like I mentioned, very used to problem, often ignored, and very rightly said. Every organization has data flowing in and from multiple systems. In fact, in the live demo, we have a billing data coming in from PostgreSQL. We have a product data coming from MySQL. So we'll definitely showcase this to all the participants over here. But moving on, how do we enable this in Snowflake? How do we create the data product? Can you just walk us through that?
Sure. So data product, as we discussed, has some core principles, some characteristics, and then so first is the most important is data. That should be high quality, reliable, business ready data sets. Metadata, they should be definitions, lineage, ownership, governance. And then last but not the least is access. It should be secure, controlled, and self-service. consumption wherever it works actually happens. Other characteristics of data product is it should be packaged, reusable and agile, and at the same time demand driven. I'll give you two examples, one in a layman language, what it means. Think of a store, a grocery store, where they keep sugar, packaged sugar for consumption. The store's responsibility is to keep the sugar fresh, clean, and always available. Whereas the consumers, which are the data consumers, they just use that same sugar. One consumer can use it for making a cake, another can use it for making ice creams, other one can make use it for making smoothies. Do you see data products, data producers are making the data available, secure, fresh, and consumers are using for different use cases. That's where the data products comes in, that we package that sugar in a way that consumers can use it for their specific curated demand-driven usage. Another good example I have is a simple way in your life you have seen your electricity sockets. So data producers here, the electricity provider is making sure your home has a data electricity power outlet. But as a consumer, you can use that socket for using a laptop, a TV, or using a kettle. So the data producers do not care how the consumer is going to use it, but they'll provide it, keep it always available, up and running, secure. But the consumers can use it in various ways. That's where it says once created, multiple usage. And I hope that example helps you understand more deeper on what is data products.
Definitely does. And you can use the sugar in your smoothie, in your coffee, in your brownie, but you need to have your sugar delivered. And that's where Hevo comes into picture. Followed by the five principle. We make sure we are delivering the data to you on time. We ingest, we orchestrate your data as per your convenience. If required, we do in-flight and post-load transformation. There's complete governance in terms of how you want to move your data, maneuver it further. And on top of it, there's an observability layer, which is telling you the health of your data pipeline and how the data is moving between a source and a destination. So ties the story fairly well. But Mandeep, let's drill further into the billing data products and what eventually we're going to show in the live demo.
Absolutely. So with a data set provided by Hevo, we got three data products under billing. We have customer data, how the billing cycle works, what plans they have, what kind of revenue we are generating. So we came up with three data products where revenue by product, growth analysis, and profitability and predictability. These are the three products which will be used by different consumers, different departments, and the downstream customers as well. We can customize it, provide it in a different way within Snowflake. We'll talk about that in a later slide. But Kushagra, can you go to the next slide, please, so I can
Sure.
go one by one on each data product. First is revenue by product, where this will talk about which plans generate the most revenue, what percentage of total revenue is enterprise versus standard, what is platinum, how much we are invoicing versus actually collecting. Is there any late fees? Is there any late payments coming up from customers? So this will give you a quick answers to your questions on our revenue generation. Can you go to the next slide, please? Second is growth analysis. This, as it obviously shows with the name, it shows you what's a growth pattern, which plant is growing faster month over month, which plants need some uh, marketing steps, some coupons to be sent out, or is it the growth accelerating, stable, or declining? Which what account, what customers, are at rate risk or churn risk of falling out if they're not using the service more than 2 3 months, maybe they might opt out. So maybe you can send them some reminders, you can send them some new deals, they can upscale, be engaged. So that's the second growth analysis product we have, which is dedicated for growth analysis. Could you go to the next slide? Okay, and the third one is profitability and predictability, where we uh, we can predict and measure the profitability of which accounts are most at risk, uh, what is each customer's estimated lifetime value, how much is our, like, are we having customers long time with us or they're going up and down, how reliable does each customer pay, are they going always skipping our payments, are they paying on time, maybe we can give them some benefits of being our loyal customers. That's what the outcome can be here from here. Who are our platform platinum, gold, silver accounts as well. So this kind of gives you overview of the whole data products as well. The three: revenue, growth, and profitability. Imagine this curated demand-driven data product was not there. Your data analyst or teams would have been querying number of times, thousands of tables, finding this, joining these separate tables into one and going from there. Now they don't have to run those various extra queries. Within two, three queries, they'll get their answers. Within a click of a button, they'll see the pattern in a graphical way. In a click of a button, they'll get real-time data. So the number of queries has gone down, the number of effort has gone down. Now they just get a curated, demand-driven, specific use case package, sugar, or a socket for your laptop specifically.
Right. That's so wonderfully put, Mandeep. In fact, this is solving a lot of problems of the mundane task which multiple teams are performing in order to get the value out of their data. But let's see how we're going to build the foundation for these layers, starting with the source systems. So you may have your SaaS application, your OLTP databases, your webhook event streams, logs, CRM-based database. You can integrate everything in near real time with CDC using Hevo. There are also freshness SLAs, complete schema drift managed, and overall reliability in terms of any kind of observability that you want to build on top of your pipeline, any type of error handling, even governance and collaboration for that matter. Then we move to the serving layer, which would be Snowflake. So you can perform all your transformations, any type of DBT model management, any feature engineering, and then particularly the delivery where we'll have semantic views, Streamlit application, secure data sharing to external customers, and these downstream products that can be used by both internal and external users. So this is the foundation that we're going to talk about today. Coming to Hevo, now Hevo, I'm not sure how many are repeat customers, but how many are new participants, how many are repeat. But just to give you a glimpse, we are a cloud-based data ELT solution. We have about 150 plus native connectors across databases, file systems, SaaS applications, REST API, webhooks, right? So you name the source, we do have that within our ecosystem. And through that, what we ensure is there is a continuous data ingestion from all these sources. And we do this ingestion for you and load it in the required destination incrementally using, again, change data capture. You can define the minutes of latency based on your SLA of your data delivery. Throughout this process, we ensure that all the source data changes are captured and propagated in your destination automatically, be it your schema level, table level, column level changes, everything. Once you have created your pipeline, the data has started coming in, all the details in terms of how fresh the data is there a lag for any object, and the quality of data being delivered is tracked, and any kind of anomaly is always alerted to you. Throughout these four steps, what we are ensuring is there's a complete reliability on your data pipeline. So any kind of failure, there are automatic retries built in. There are fault tolerant mechanisms that we follow. So there is guaranteed delivery of data from your source system to your destination so that none of your downstream tasks are affected. That's how you build a data pipeline. Just to give you a glimpse, we'll of course go into a live demo from scratch.
Other it's
Sure.
interesting to see you have MongoDB as well. That's interesting to have unstructured data coming in as well as a connector. That's interesting.
Right. We do cover all the NoSQL, SQL-based connectors as part of our database ecosystem. So yeah, MongoDB, DynamoDB, all of these OLTP NoSQLs are also covered. Moving to activation of these data products, Mandeep, just take us through how we can create a product. Just help us through all of these architectural points.
Yeah, absolutely. So once we get the data ingested by Hevo within Snowflake ecosystem, we have various tools within Snowflake. They have enabled it with a lot of tools where we can do for C-level executive, for your downstream, for using AI. You can have various functions. For example, Streamlit. That is uh, a lightweight app where you can have the data graphically represented. You can see quickly what the percentage is. You can do a backend Python programming where you can represent the data in a graphical manner, helping the C executive to see it nicely, meaning data doesn't leave out of Snowflake, data stays within Snowflake. It's like kind of a Power BI dashboard. You can get a whole extensive dashboard with all the bells and whistles of buttons, graphs, pie charts. We'll see that demo as well when we go to the next slide. Cortex, they're a huge. If you go back a little bit, one slide back, Kushagra.
Yeah.
Cortex semantic views, AI-driven functions, extensive details there. We can have a semantic view where your data analyst can go and ask questions in a layman English language LLM, just asking questions, and they'll get answers. And this query, SQL query, and the dashboard snippet of the data as well. We'll go through that too. Secure data sharing, this is where your downstream comes, where we want to share that data with your downstream consumers, and we can share that securely encrypted, and only they can see the data. And then Cortex Code, that's another tool recently onboarded, which is uh, like an autopilot for you. You can just type your question, type your requirement, it will build it for you. You can build a Streamlit app, you can build a Cortex semantic view, you can create all the DDLs, what you can understand your data, metadata, and it can be a assistant for you within Snowflake. We'll see all of these quick demo in the next slides and go from there. So Kushagra, can go to the next slide for the AI functions. I can just briefly talk about them.
I I was way too excited for the AI slide, hence I moved quickly. But yeah, there it is. Yeah,
Yeah, so there, this is the complete feature overview, which is more specific to data products and how we can enhance your data so it adds a value. So if you see SQL functions, we have classify, filter, sentiments. It can read your data and give you a sentiment. Is it positive? Is it negative? Aggregation, extract. It can extract your PDFs, your documents, same as in AI skill functions, complete is where you can generate your descriptions of your columns, describe, parse the document, uh, and then Cortex functions. Cortex is where you have Cortex analyst, where you can do LLM questions to your Cortex analyst, Cortex search, which is for your unstructured data, Cortex agents, very important, where you can add your custom tools. That could be semantic views, that could be your stored procedures, UDFs, where you can ask questions. It's pretty amazing how it works. It can give you accurate answers. And then on top of that, Snowflake Intelligence, all of the top of those three can be embedded into Snowflake Intelligence. It's kind of using your Claude or your ChatGPT model and then adding tools to it, adding those powers of agents, search, and analysts. So you can, within the same window, you can ask all the questions on your data. And then we also have ML prediction models, anomaly detection, forecasting, classification, regression, Arctic LLM. The list is unending. But we'll cover off some of them today, and then hopefully we can cover more detailed one in future seminars.
sure. So what you'll see today is a live creation of pipeline bringing data from these OLTP sources. Like I mentioned, our MySQL comprises of a product data, our Postgre comprises of billing data. So we'll be creating a live pipeline on that, sync this data in minutes into Snowflake. Then once the data is landed into Snowflake using that raw data, Mandeep will show us how a product is created, followed by the delivery of that product using Streamlit and Semantic View, and then how we can share this further to any internal or external user using data sharing. So it's time for a demo. I'll just move to the Hevo UI. Just give me a quick check, guys, if you can see it.
You can see.
Great. So this is the landing page of Hevo Data. Like I mentioned in my description, we are a complete SaaS-based ELT offering. And what you're seeing right now are the pipelines running in from a specific source, pushing data into a particular destination. You can already see a pipeline billing running, which is effectively giving data to Mandeep already for empowering his products. But how do we do it from scratch? So you'll see there's a create pipeline button on the top right side. As I just click on it, I'm redirected to this directory of sources, which has about 150 plus connectors segregated across various verticals. So you have databases and file systems, which cover all the SQL-based, NoSQL-based databases, even file-based systems. Then comes engineering and analytics based sources. So let's say in case you want to specify a payload to be sent from a webhook in your destination, in case you want to connect a specific REST endpoint, you can even have a REST API connector utilized. Finance and accounting based sources for tracking in all your finance specific or payment specific data. Marketing based sources, so all your ad platforms, your CRMs are listed down over here. Product specific data, so WordPress, Magento, all your website specific data can be also connected. And finally, sales and support analytics. So all your supporting tools like Zendesk, Freshdesk, Intercom are also listed. So overall 150 plus directory of connectors. I'll just go ahead and create a pipeline for Postgre, which captures our billing data. As I select on Postgre, what I am being asked is, hey, where you want to move your data? There are multiple destination options in form of OLAPs like BigQuery, Snowflake, Redshift, Databricks, and OLTP like Postgre, SQL Server, and MySQL. Based on our use case, we'll just choose Snowflake and move ahead. Now, for every database or in our nomenclature, a log-based source, there is a specific method of connectivity. Now, because we have utilized Postgre, he was offering you two methods of connectivity. First is your write-ahead logs, which are exposed again at the source level by the Postgre DBA admin. So what you can do is just enable these logs, and Hevo will utilize these write-ahead logs for capturing any kind of data as it changes. So any insert, update, or delete, everything will be captured once we have access to these logs. So this is called the logical replication methods. But when it comes to billing systems like legacy billing application, which might be used from by various other peoples, and effectively, if you do not want to expose logs for such systems, such old systems, there are fields which are system-based fields within Postgre called xmin, which are also tracking the data incrementally within the database, and you can utilize those xmin fields as well for capturing your data incrementally. There are other two modes like table and custom SQL. In case you do not have xmin reliability or logs available, you can have either a specific table selected to have a full refresh of this table every time you want, or maybe a specific query based on which you capture an output you want to push into your destination. You can use a custom SQL option. I'll move ahead because we have a billing system, a old system. Let's move ahead and create pipeline with xmin. Now comes our source configuration page. I'll just provide the details. So basic details like hostname, username, what is going to be my password. I hope I get it right in the first time. And my database name. Now, in case you require an advanced connectivity, probably your system does not need to be exposed in the public internet. In case you want to route your connections via secure tunnel, you can use the SSH option for mission critical data, maybe all important encryption methodology that you want to utilize using your certificates, their SSL option. Further connectivity like a private link, a VPC pairing, a VPN-based connection, we are completely open in terms of how you want to connect with your data because we provide all of these. Then comes the second step, which is configuring your destination further. I already have multiple Snowflake destinations, so I'll be just providing Mandeep data in one of that destination. So I'll just select my Snowflake destination over here. Now, once you select your destination, whatever destination that you've chosen, you want to validate, okay, probably if you are moving the data into a right warehouse or a database, you can just validate once you have selected that destination and further continue. It will again validate the credentials and push us to the pipeline configuration page, which is where we are actually setting up how the data will be taken out from the source and pushed into a specific destination. So let our creds be validated. Great. Now, this is one of the most important step in the pipeline creation process. Firstly, let's name this pipeline, maybe Postgre SQL webinar. Once I name the pipeline, I'm being asked a prefix. A prefix becomes really important when you have one destination, but you want to utilize the same destination when if you're bringing data from disparate sources. There will be a specific schema differentiation created at your destination to identify data coming in from individual source system, even if you're utilizing one destination. So prefix is an important differentiator to maintain those naming conventions, to maintain that transparency, and also a validation check towards your Snowflake destination in terms of the disparate sources being loaded in specific schemas. So I'll just name it PG SQL. Now, the first stop, what type of load that you want to do. We offer two types of load. One is a merge technique. Again, very classic upsert method. In case there is new information found for existing records, you update it. In case no match exists, you insert that data. But if you want to maintain auditability, you don't want to modify any kind of existing data or delete rather any existing data, but still continue to add that, you can choose the second option, which is the append mode. Talking about reliability, talking about how we are building that fault tolerance, you'll see by default for any pipeline, there will be a moderate failure handling policy, which is asking you that, hey, in case of failure, how do you want us to behave, right? So first option is do not load any data in case there's even a single failure, right? A very extreme way, but still in case you want to govern the pipeline that way, you can select that option. In case there are less than 10,000 failed records, you can still continue to load. This is a moderate option which is already selected. Moving forward, we would want to customize this for the user so that him or her can define the failure handling policy themselves. As we are moving data, we are also ensuring the source changes are being propagated, replicated, adapted at the destination on the fly, and also is suiting the user's need of how he wants to maneuver the source schema into destination, right? So hence there are three options available. First being allow all changes. So with this option, any new schema, table, or column which exists in your existing table will be changed to the destination table on the fly. If you just want the reverse of it, you do not want to maintain any new changes, you can block all the changes at the schema level, or certain backfilling transactions. For example, you want to just sync your new columns of existing table with the destination, not the entire schema or table. You can choose the third option. The most popular one when multiple systems are being pushed is changing the data on the fly. So we'll stick to the first option. Whenever we talk about the ELT landscape, there are two types of workloads. One is a historical workload, which is capturing all your past data. And then there is the incremental load, which is the point in time data, which you want to, start moving every day. We provide you an option in case you want to do both loads, historical and incremental. You can choose this replication type. Or in case you want to just maintain the new changes without performing any historical load, you can also choose the incremental only option. The pen ultimate step over here would be, how do you want us to sync your data? How often you want us to, take data from the source and push it into destination, which is where frequency of the pipeline run comes into play. So you can go every hour, maybe select this a duration between 1 to 24 hours. In case you want a faster data, you can see we can go as low as every 5 minutes also. I'll keep this to every 5 minutes. But what about ad hoc use cases, ad hoc analytics? Maybe there's a sudden request that, hey, we cannot handle this load. We do not require this load at this point of time, but there might be a peak, period at the end of the month where you require a certain data. In that case, there's also a sync on demand, which is creating your pipeline without any schedule. What you can do is just utilize the API, put it in your Airflow, and run it as per your convenience through an external orchestration, of course, when you require it. So there's also sync on demand, which you can utilize Hevo pipeline running from Airflow. Lastly, latency becomes a very important factor, and we do want to make sure that you're getting notified for latency based, because everybody follows SLA and they want to make sure they know how fast or how slow the data is moving. So you can be alerted when a specific threshold of a pipeline latency is crossed. So you can define that latency alert over here. That was all things about pipeline configuration. In very simple steps, we have covered a lot of aspects, be it failure handling, schema drifts, different type of replication and sync types. Fourth step would be just looking at all the objects that you want to move. Like I mentioned, Mandeep already has those objects. So you can see this is the billing data comprised of cycles, contracts, plans. Mandeep will tell us how he's going to utilize it further for the products. I'll select all for now and continue, verify all my details, source, destination, pipeline, and save this pipeline. Just a simple 5-step process and your pipelines are done. Do have a ready pipeline with me. So I'll just
Vishal, one question. So just on the security side, is it support private link and is it encrypted in transit?
yeah, it is. It is encrypted at rest and in transit.
Okay, thank you.
Right. So what you're seeing right now is a running pipeline. This is how a pipeline will look when you have saved it. And you can see this was created for every 6 hours. You can always go edit these details even after the pipeline is created. So it's not like you have to go on and create a new pipeline. The first job is always historical, and you can look at it in a granular way. You can see this is a historical job. You can download the session logs for how the data is being moved from. For this historical job, you can further enrich these logs within your CloudWatch and Event Hub for further analysis. Looking at all the objects that you have here, you can see every object name will have its ingestion and load stages, and you'll be notified how much time did it take. So a lot of intrinsic information is being provided at an object level, so that you're completely aware of how much time it is taking for you to receive your data from the system that you desire. So granular level details at the object level, also a summary of, okay, how much time the entire job took, how many objects did it move. Everything is given to you. Followed by the next job will be incremental. Now, because we don't have incremental data coming in, you can see nothing loaded. But after historical, every other job would be an incremental job. You can always, like I mentioned, go on, edit any details that you want on the fly. You don't need to create a pipeline again. Revisit your objects in case you want to resync any object. You can go on and just resync that object. You, again, do not need to be dependent on the entire pipeline. You can operate at an object level once the pipeline is created. And finally, every activity, right from the pipeline creation to any object level changes to any edits that have been done on the pipeline, right, is logged. So when multiple people are collaborating, right, within a pipeline, what kind of activity was done by which user. It maintains accountability whenever large scale migrations are happening from multiple source systems into a specific destination. Talking about collaboration and governance, We also have a robust alerting system. So as I click on alerts over here, you'll see all my pipelines which are subscribed to multiple alerts. You can add or remove your pipeline from subscription for alerts. But alerts are also defined in three formats: critical, high, and warning based alerts, which cover multiple areas, be it your job failure, specifically in case of Postgre, any wall that needs to be monitored, any deletion of pipeline, any skipped job. So entire aspect from pipeline creation to a fully stable running pipeline are covered within these scenarios. You can go on, add your DL, add your particular team member, so that you can receive these alerts, and based on that, you can proactively respond. And not just at the email level, we have these alerts also at a Slack level, and you can always integrate third party tools like Opsgenie, PagerDuty for acting on these alerts proactively. Now, for anything which is happening between your pipeline creation to a stable pipeline running, in case you still need support, you'll see this chat option over here. We have 24/7 chat engineers, support engineers with you, so you can always write your query and there will be someone to help you out. So this was about how simple and effective it is to create a pipeline in Hevo, talking about the principles that we have built it on. Now that, Mandeep, we have received the data, really looking forward for you to tell us how now we build the data product itself. Over to you.
Thank you, Kushagra. Let me see if I can share my screen. Yep, I can do it. Let me know when you can see my screen.
I can.
Kushagra, can you see my screen?
Yeah, I can.
Okay, thank you so much. So this is where the second half of the fun starts. Hevo did his magic. We got the data. That's the database we have, PostgreSQL billing. We have billing cycles, and the columns we have account ID, billing ID, created time, paid date, payment method, payment status, have contracts, what kind of contracts we have, what's the USD value on that, monthly revenue generation, end date, credit date, terms of month. We're getting all those data which Kushagra just ingested. We have the plans, what kind of plan we have, what the plan ID, plan name here, and the seats, and the usage events, how the customers, the consumers are using those categories of their memberships, what's the indulgence. So that's what data we have received within Snowflake. Using these five tables, we will create our data products as we discussed about revenue generation, growth analysis, and profitability. Starting with data products. So I'll create a new database called EDM, DPEDM, meaning Data Product Enterprise Data Management. And then I'll create a schema, which will be billing data products, leaving a comment as well, which talks about analytical data products building for Postgres billing source tables. The layer one is a base smart view, and then we'll join all five sort tables into one clean, denormalized row per billing cycle. So these are my DDLs which I'm going to run, which will be doing the first the base billing mart, where I'm going to calculate the due dates, paid or not. Then I'll have my revenue generation data product view, where I'm again calculating the case statements, is it at time and failed or overdue on the payment structure. Then I have the growth analysis, what's the trend, how the growth is going, which are the areas, what are the areas where there's more attention required from different teams. And I'll calculate those metrics here just in the view. And then last is will be the profitability view, where I'll have the account ID, current plan name, and what's the metric on the profitability. Is it going to go increase, go or decrease? Payment health, is it always failing, or is it getting late, overdue? I'll calculate all those stuff. Once I have this views ready, I have now various ways to how I can empower and enable these data products with the downstream or my internal teams, or I can do it from a C-level executives as well. First, we'll start with Streamlit. That is where we can graphically show them the data. So we were talking about AI functions. This is our Cortex code, also called as Coco. What I can do here is I can just simply prompt create Streamlit app for me, which shows the metrics from PS, SQL, billing database, and provides me all the uh, graphs and information for decision making. So what Cortex Code will do is will take my prompt, generate a Streamlit app for me, the way it's done here. I can simply go in and do it. I don't have to write all this code. All I can do is I can just tweak some cosmetic changes, some data changes I can do. All I can do is when this is done, I can create this, I can copy it and use it in a Streamlit app. While this runs, I can show you how it looks like. This is the Streamlit tab, which have three data products. I have revenue by product, growth analysis, and profitability all in one dashboard. Data doesn't go out. Everything is within Snowflake. I can see here the total monthly revenue, the invoice was collected, payment health plan, everything looks good. I have all the numbers handy. I can give it to my leadership real quick. I can take them a screenshot, provide them real quick. They don't have to run queries. They don't have to go and fetch data. They don't have to run multiple running queries to find out where data belong, what changed. In this one chart, they can come and see what's happening. Growth analysis, same thing. I have the net new, monthly revenue, monthly by monthly plan. I have all those plans, enterprise, enterprise plus, professional, what's going up, what's going down. Cumulative MRR plan, again, a nice way to see, should to present to your leadership to understand where is what's going on and taking the decisions. This gives you extensive dashboarding within Snowflake. Data doesn't go out, it's in there, it's secured and governed. So this is one way you can have the data product represented in a graphical manner. It says key metrics. I have total 30 accounts. I have high churn risk. That means two customers are probable they're gonna leave out or go out, opt out of our membership. So I can probably send them some, the marketing team can see this and maybe in those that category of customers or geographical area can start some uh, coupons or marketing deals. That way they come back and be motivated to be part of it. Our profit, upsell opportunities. To see, it's an extensive dashboard you can use just from your data products. You don't have to write numerous queries. So this was the first part where we are talking about semantic streamlit apps. Now I'm going to show you about semantic views. That's where we're gonna have, this is another Cortex analyst function where you can kind of have curated, calculated metrics already provided for your team, and they can just write a question and they'll get the answer. They don't have to even write a query anymore. They can just write what is what and it will show you what it can take out. This is the syntax for a semantic view where I have my tables, dimensions, and metrics, what I'm calculating here. Total collected revenue, different total MMR, average collection rate, total revenue gap, total failed payments. This is all I'm calculating within my semantic view. That it means it gives the accurate answer, pinpoint answer. That way there's no redundant details or data coming out. So once I take this semantic view, I can take it back in the semantic view viewer. If you see my question, just the question I added. asked. I can ask that again. So semantic view is another way I can enable my consumers, data consumers to go in, see the data, get the query as well. And if needed, they can tweak the query. So you see, giving them an accurate query, I don't have to go in and try different uh, columns, try different group buys, order by, or even joins. I have one shot, I have what I can get, looks good, I have a query as well. So this is another way we can enable the consumers for accessing data from semantic views, and it is more accurate. And this skills also give you physical query as well. Going to the second part is where we can talk about the downstream data share. So we enabled Streamlit app for C-level executive. We got Cortex analysts for people who are not SQL handy. They don't know much in SQL. They can just write queries here, put prompt, and they'll get the data. Now we're going to talk about, let's say, Kushagra has a downstream team sitting in a different region, a different Snowflake account, and we want to send them data securely, governed, and controlled. What you can do is we can create a share, and that's the syntax for that. And you create a share, you give the usage on that database to that share, to the schema, and to the tables. Once that is done, I can just run this command. This is our downstream consumer where we have to add the access for this data share. Once I do this, this is my target account where I enable the data share. So if you see, if I go here and I go external sharing, I'll see a direct data share coming here, billing data products, which I enabled. And from the customer account, this is the customer account, I can just query the data real time. The moment Kushagra makes an update, I will have that data here, and I have all those tables coming out here. So what we showed is semantic views, Streamlit app, and now data sharing all across the data product which you have built, different use cases, different consumers, the same data. So coming back to our example, same electric socket, but used by a laptop, used by a kettle or a TV. One more thing another use case I can give you is, what if you want to give access to your existing team members on a team in your team? We can create a role. We can create a specific role for data marketing analysis or sales analyst, and we can give them specific access to that specific table, so they can go and query data as well. Apart from semantic tables, semantic views, Streamlit tab, data sharing, internally also you can do that. Uh, I think that's pretty much from my side. I've covered three data products, how we can enable them, and how those same data product can be leveraged and used on different ways and different audience and different consumers. Back to you, Kushagra.
Thank you, Mandeep. That was really insightful. I'll again start sharing my screen. So how are the next steps looking like, right? If you want to build this today, you can have a free trial of Hevo created. We have a 14-day free trial window. No credit card, no call required. You can just go on, sign in like you sign in your Gmail account and create your account in Hevo. If you want, we can help you with resources of a personalized demo wherein we talk about your specific source system to be integrated, how we can help you integrating it. And in case you need any resources further for that, we can help you. And finally, while Mandeep helped us, walk through multiple aspects how you can create a product. In case you need to discuss this further with him, in case you need more help, you can always connect with him on LinkedIn. We'll also share these resources later as well. Now, with the time in hand, I'll just open up to the Q&A. In case you have any questions from whatever we have discussed so far, please feel free to drop them. Right.
I see there's one question.
I'll take the first one. Can I can a client just drop in a file via SFTP and we can load that in S3 or Postgre and create pipeline using Hevo to land the data in Snowflake? I'm not sure if I fully get it, but you can create a pipeline which moves data from SFTP to S3 and Postgre. And then in case you want to directly load this data from Postgre to Snowflake, you can create a second pipeline from Postgre to Snowflake. So these are all overlapping source and destination which are available. So yeah, the use case is possible in steps. How is this pipeline better for incremental loading than dbt's incremental loading? The short answer is it's saving you time. You're not writing any kind of a code. You don't have to maintain that code. And what essentially this helps you is to scale and add more and more sources. So incremental loading, we are taking care of for you as we read the logs based on your schedule. You don't have to maintain your particular logic for incremental replication. Hevo does it for you. Any more questions?
Yeah, meanwhile we wait for questions. I would really recommend people to also try a Snowflake, open a trial account, try these ways, have a Hevo trial account, build that pipeline end to end, have a demo in Snowflake, create a demo account in Snowflake, ingest that data, create those different ways of how data products can be leveraged. I think it will be good project for you to learn how it works.
Definitely. I see there's one more question. How does it decide on unique keys? I believe this is again on the pipeline incremental loading. So to answer your question, we read from the logs. That's first step. And overall architecture of Hevo is based on inference-based engine. So when you're inferring the schema from the source, by default, all the unique constraints which are implied on the source are being propagated in your destination. If not sure I can see the name, but if in case you require a personalized demo, I can answer more of your questions on a deeper level of how we are actually moving data from a particular source to the destination. All right, we have a few more minutes. Folks, please drop your questions for me and for Mandeep.
Yeah, any question on Snowflake side? And yeah, feel free to reach out to me on LinkedIn. Happy to discuss more in depth. I also do free Snowflake classes. If you want to join those, I do free training. That is also we can discuss. But happy to have any other questions which you remember later. Let's catch up on LinkedIn as well. But yeah, let's give 1 or 2 minutes more for more questions, and then we can go next step.
Sure, let's wait for a couple of more minutes. Guys, please, if you have any question on anything that we have discussed today, please drop your questions.
Shagar, I think if we don't have any more questions, I think
Sure.
I would like to just thank the whole Hevo team for this collaboration. It was a great effort and great run. Looking forward for more collaborations in the future. Be happy to be part of it. Thank you so much.
Thank you. Thank you, Mandeep. Thank you for taking out time and helping us, with all the different insights that you gave us through Snowflake. Thank you so much. All right,
Sure.
then we'll call it a day. In case you have any questions, please do reach out to us async. You can always reach out to Mandeep on LinkedIn.